Welcome my dear learners for this course on engineering graphics. In this module 2 we were discussing on orthographic projection of plane surfaces. So far we have solved 24 problems on orthographic projection of plane surfaces. Moving ahead, the problem number 25 of our discussion states that a hexagonal lamina of sides 25 mm rests on one of its corners on HP. The corner opposite to the corner on which it rests is 35 mm above HP. And the diagonal passing to the corner on which it rests is inclined at 30 degrees to VP. Draw its projection. Find the inclination of the surface with HP. So we have an hexagonal laminae of sides 25 mm resting on one of its corners on HP. So first position, I want to get the corner towards my left hand side. It is resting on horizontal plane on one of its corners. So let me draw XY line and take corner towards my left hand side. Let us draw XY line, drawn. So this is X, this is vertical plane and horizontal plane for first angle projection. I want to get corner towards my left hand side, so therefore draw an horizontal line equal to the edge length of the hexagon, which is 25 mm. Using this as reference, you construct a circle. Construct a circle using this as a reference. Done. Now cut arcs at equal intervals. Cut arcs at equal intervals and join these arcs to complete the hexagon. Now connect these corners. So we have the corners of hexagon. Done. Now call these corners as A, B, C, D, E and F. The side length of this hexagon is given in the question, which is 25 mm. Now take the vertical projection. Take the vertical projection and complete the sketch. That is, complete the front view in its first position. So the laminal length is 50 mm, as it is the diameter of the base circle which is used to construct the hexagon. Now call this as A dash, B dash is visible, F dash is invisible, C dash is visible, E dash is invisible, and we have D dash. Now it is resting on corner A is what I want to make. The corner opposite the resting corner is at a height of 35 mm, he says, above HP. So therefore measure 35 mm above horizontal plane. Measure 35 mm above horizontal plane. Measure 35 mm above horizontal plane. Take a reference line at a height of 35 mm. Take a reference line at a height of 35 mm. Taken. Now make it rest at A dash and cut an arc for 10 centimeters. Sorry, 5 centimeters, correct? It is 25 mm radius, 50 mm diameter. So cut an arc. Done. Now join this to get the laminae A dash D dash. Join this, that completes the laminae A dash D dash. So I got A dash D dash and also mark the remaining corners, that is B dash F dash C dash E dash C dash E dash. Now this angle is what he is asking us to calculate. Now if I use compass and measure how much is the angle, so I am getting the angle as 45 degrees. I am getting the angle as 45 degrees. 45 degrees is the answer I am getting. That is what he has asked. Find the inclination of the surface with horizontal plane. The answer is 45 degrees. Let us complete the problem. Take vertical and horizontal projection. So this is till A. We have B and F. We have C and E. We have C and E. And finally we have D. Finally we have D. So this is D till the end. We have B and C. We have B and C. And we have F and D. We have F and D. Now connect these corners. Connect these corners. A, B, C, D, E and F. So A, B, C, D, E and F. Done. Now he says that the diagonal passing through the corner, that is AD, is inclined at 30 degrees to VP. So since AD is inclined 30 degrees to VP, AD is not retaining its original dimension. Originally it was 50 millimeters, that is diameter of the circle. Now it is reduced. So therefore I should go for beta angle. He is not stating it is appears to be, or in the top view he is giving the true inclination. So therefore go for beta angle. So draw a reference line. Draw a reference line which is parallel to XY line and measure 30 degrees on this line and compute beta. So measure 30 degrees on this line, measuring 30 degrees. I drawn 30 degrees. So on this line I will mark the true diagonal. True diagonal is known, which is 50 mm. So mark 50 mm true diagonal. Done. And mark true diagonal 50 mm. So I will call this as A. So AD true diagonal is marked. Now I will fix the locus. I will fix the locus. Locus of D is fixed. So this is locus of D fixed. Now using compass, intersect this new locus, fixing A, intersect D. So fixing A, I will intersect D. Done. So this is what I required. Required D is obtained. So I got AD, connect AD and extend it back to find the beta. So initially we had 30 degrees true inclination and now we had beta. So how much is beta? Calculate beta. Calculating beta. Beta is turning out to be 44 degrees. Beta is turning out to be 44 degrees. Beta is turning out to be 44 degrees for me. Now I have AD. So measure these lengths, transfer them. So measure those lengths and transfer them. So measure those lengths and transfer them. Transferred. And also FB and EC are perpendicular to AD, and AD is a perpendicular bisector to these two parallel lines. So therefore transfer them here, which are perpendicular to AD. So draw perpendicular to AD. AD is a perpendicular bisector for these two parallel lines. So transfer them. Done. Transferred. So now connect these corners, A to B, B to C, C to D, D to E, E to F, and F to A. Done. Now take vertical projection to complete the sketch. We have B, C, D, E and F. Now take vertical projection. So this is our XY line. First I am getting B. So drop till B. Then we have A. It is resting on A. Then we have C. We have C. Then we have F. Then we have D. And finally we have E. We have till E, and then we have F. Now connect this. We have A to B, B to C, C to D, D to E, E to F, then F to A. That is A dash, B dash, C dash, D dash, E dash and F dash. So this is a complete solution for problem number 25. Moving ahead, the problem number 26 states that a hexagonal lamina of sides 25 mm rests on one of its sides on vertical plane. The side opposite to the side on which it rests is 30 mm in front of VP, and the side on which it rests makes 45 degrees to HP. Draw its projections. Also determine the inclination of the laminae with the reference plane. We have an hexagonal lamina resting on one of its sides on vertical plane. Since it is resting on vertical plane, the second position should show inclination with respect to vertical plane itself. That is what he has given. The side opposite to the side on which it rests is 30 mm in front of VP. Finally, I should show inclination with respect to HP. The resting side makes 45 degrees to HP. Come, let us solve this problem. We have an hexagonal laminae resting on one of its sides on HP. So let us draw XY line. Draw XY line. Drawn. This is X, this is VP, this is HP. Now I want hexagon to be in the vertical plane because it is resting on VP on one of its sides, correct? So therefore I should get side on either side, for which I should take vertical line and then construct. So take vertical line of length is equal to the side length, that is 25 mm, using which you construct a circle. So construct a circle. So I am constructing the circle Now cut arcs at equal intervals. Cut arcs at equal intervals. Done. Now join these arcs. So join these arcs to get the hexagon. Done. I joined all these corners. That completes the required hexagon. That is A dash, B dash, C dash, D dash, E dash and F dash. Now take vertical projection. So side length is given for us. Each of this side is measuring 25 mm given in the question. Now take projection. Take vertical projection and complete the top view. So take vertical projection and complete the top view. So this is the top view, right? So I got the top view. Now this is A, B is invisible, F, C is invisible, E, D is invisible. Since it is resting on VP, the second position should show inclination with respect to VP itself. He says that edge opposite to the resting edge is inclined an angle of, is at a distance of 35 mm in front of VP. Correct? Opposite side on which it rests is 30 mm in front of VP. So therefore measure 30 mm in front of VP. So measure 30 mm in front of VP. Measured. So draw a reference line. So draw a reference line 30 mm in front of VP. Drawn. Now measure the lamina length and transfer the lamina. Measured the lamina length and transfer the lamina. Lamina is transferred. Right. So it is resting on AB. So it should come towards HP. I'll mark it towards HP. Lamina is transferred. Also mark the center of this lamina. Done. So this is AB, FC and ED. Clear? Done. So this distance is given as 30 mm. He is asking to find what is this angle. So calculate that angle. That is also asked in the question. Calculate the inclination of the lamina. So use compass and find how much is the inclination. So if I calculate the inclination, I am getting the inclination as 44 degrees. I am getting the inclination as 44 degrees. Now take vertical and horizontal projection and complete the sketch. Take vertical and horizontal projection. Take AB, we have FC, corners FC, and we have corners ED. So this is F, this is E and D, E and D, and finally we have C. Done. Now join these things. We have AB, C, BC, D, then E, finally F, and again connect to A. That is A dash, B dash, C dash, D dash, E dash, and F dash. Now finally what he says, I want to show inclination with respect to HP now in the final position, correct? The side opposite to the side on which it rests is 30 mm in front of VP, and the side on which it rests makes 45 degrees to HP. On what side it is resting? It is resting on side A dash, B dash, right? It is resting on side AB. Here is the side on which it is resting. So therefore AB, A dash, B dash should incline at an angle of 45 degrees to HP. So let me incline it at an angle of 45 degrees to HP. So for which I will measure 45 degree line. Measure 45 degree line. Measure 45 degrees. Now draw 45 degree reference line. Drawn. On this 45 degree line, AB should come and sit. AB is maintaining the true dimension of 25. So measure 25 on this line. Measure 25 mm on this line. So I'll measure 25 mm. Measure 25. This is A dash. This is B dash. And this is required 25 mm side length on which it is resting, and that side is making 45 degrees to HP, correct? Now I can measure AE and transfer it. Measure AE and transfer it. Transferred. And also measure BD and transfer. Transferred. So I got D dash and E dash. So first I had drawn A dash, D dash, then transferred A dash, E dash and A dash, D dash. Now use compass and find C dash and F dash. Now use compass and find C dash and F dash. Now using compass you find C dash and F dash. Now connect these points A dash, B dash, C dash, D dash, E dash, then F dash, then again A dash. A, B, C, D, E and F. Now take vertical projection and horizontal projection, complete the drawing. We have ED, we have ED, then we have FC. We have FC. So C is still here. We have D. Adjacent to that we have D. Then we have B. A dash, B dash is here itself. It is resting on A dash, B dash. Then we have F dash. then we have E dash. D dash should be drawn properly. C dash and D dash. Done. So that is, we have AB, then C, then D, then E, F, and then A. That is A, B, C, D, E, F, A. So this is reference line X, Y. So this is the solution for problem number 26. So we have discussed the solution for problem number 25 and 26. This completes our discussion on hexagonal laminae. From next lecture, I will take up circular laminae. That's all from this lecture. Thank you all.